This video aims to make you familiar with the entire Docker concept. In the previous video, we have discussed traditional deployment, virtualization, and containerization. Consider watching that as well. Docker packages application and all their dependencies into lightweight, portable containers that run consistently and efficiently in any environment. You can containerize web servers, application servers, databases, and every application services you can think of. You have application code and dependencies. Your device has the Docker engine installed. You write a Docker file. This gives instruction to the Docker engine to package your application into Docker image. This image is stored locally in the host. For version control and distribution, it is tagged and pushed to an image registry, that is Docker Hub. Image repository may be public or private. You can pull the image from Docker Hub and run the container. This container serves your application. To update the application, you need to update application code, build Docker image again, and repeat the process. Docker follows client-server architecture. There is a Docker client, Docker host, and image registry. Docker client is a GUI or CLI used to talk with Docker host. Docker host has a Docker daemon, Docker images stored locally, and running or stopped containers if any. Image registry like Docker Hub maintains Docker images, extensions, and plugins. When running Docker run nginx via Docker client, the Docker daemon checks if an image is present locally. If not, it pulls the image from the registry, stores locally, and creates the container with that image. I have the Docker engine running in my system. Docker CLI is also installed in the same system. Let's create and run a container. Docker run command creates and runs a container. This is port mapping. This runs the container process in the background. This is the nginx image. It is unable to find image locally. Since I'm not using any tag, it is using default tag latest. Docker engine pulls the image. Finally, our container is created. This is our container recently created. Our application is served on TCP port 80. Since we have done container to host port mapping, we can access nginx from our browser. Docker stop with name of the container stops the container. This removes the container. How does Docker work? The command issued from the Docker CLI is converted into an API request. API request is sent to Docker daemon. Dockerd handles tasks such as image management, network management using network library, storage using storage drivers, and resource configuration. It then delegates container execution to containerd, the core container runtime. It manages the container lifecycle. To start the container, containerd uses a low-level runtime called runc. During container creation, Linux namespaces provide isolation, while C groups control and allocate resources. Once configured, the containerized application process starts. Containers are ephemeral by nature. When the container is removed, any data stored inside the container is also lost. To persist data beyond the lifecycle of a container, Docker provides volumes. When a volume is mounted to a container, data written by the application is stored in the volume instead of the container file system. Even if the container stops, crashes, or is replaced with a new version, the data remains intact in the volume. This volume can be remounted to another container. This makes volume ideal for databases, application data, logs, and any stateful workloads that require persistent storage. Containers rarely work in isolation. They often need to communicate with other containers, external services, and users. Docker networking enables this communication while maintaining isolation between containers. Docker network assigns each container an IP address. Containers on the same Docker network can communicate with each other using the container's name, while external users can access containerized application through published ports. Docker can have these networks. The bridge network is the default network driver used by Docker on a single host. Containers connected to the same bridge network can communicate with each other using their IP address or container's name. External access is provided through port mapping. With the host network, containers share the host network stack. Container does not get its own IP address and uses the host interface directly. It is used when maximum network performance is required. An overlay network connects containers running on a different Docker host. Docker creates a virtual network spanning multiple servers, allowing containers to communicate as if they were on the same network. It is used in Docker Swarm clusters. The MAC VLAN network assigns a unique MAC address and IP address to each container, making it appear as a physical device on the network. It is used when containers need their own network identity. The non-network completely disables networking for the container. The container gets only a loopback interface and cannot communicate externally. It is used for isolated or security-sensitive workloads. Dockerfile is used to create the Docker image. Here I have Dockerfile, requirements.txt file, and simple application code. A Docker file defines everything needed for an application, including base image, dependencies, application code, environment variables, exposed ports, and startup commands. Let's build the image. This will be the name of our image. This is the name and this is the tag. This is our image. We can use this image to create a container. The container is created. It is being served in TCP port 5000. Our application is being served in localhost port 5000. Modern applications often consist of multiple containers, such as web servers, databases, and cache. Managing each container individually can quickly become complex. Docker Compose simplifies this by allowing you to define and manage multi-container application using a single YAML file. Docker Compose can manage multiple containers. In the Compose file, you can specify services, images, environment variables, dependencies, volumes, and networks. When the Docker Compose op command is executed, Docker Compose automatically creates and starts all the required containers and connects them together. This makes it easy to deploy, update, and manage an entire application stack with a single command. If you like this type of content, consider subscribing to this channel. Thank you for watching.